We're on number 19. A television news editor would like to know how local registered voters would respond to the question, are you in favor of the school bond measure that will be voted on in an upcoming special election? That question itself, does that seem bad or not bad?
Bad.
What about it looks bad?
It says favor. So, like, are you support?
But it's saying yes or no. So is there really anything that leads you in a direction for that? I don't really see anything terrible with that. A television survey is conducted during a break in the evening news by listing two telephone numbers side by side on the screen, one for viewers to call if they approve and the other to call if they disapprove. What are issues with that sentence?
Evening news.
What about the evening news?
Some people don't watch it.
Alright, so the only way that you are going to possibly know about this survey is if you are physically watching the evening news. Some people don't watch it. Some people can't watch it. Some people are doing something else. So, what is it called that that only those who were actually watching this would be able to be possible to participate?
Would the survey being on the television mean anything? Because, like, people who are
Yeah, I'm wrapping that up. I'm tying that all together, yes. Undercoverage. So undercoverage is some groups left out of the possibility to participate. Those not watching the news wouldn't know that they could participate. Those who didn't have a TV would not be able to participate. That also applies to the part of the phone. So if you didn't have a phone, you couldn't participate. If you weren't watching it to call in, you couldn't participate. So undercoverage is a possible issue there. What is another issue that is addressed in that sentence?
well, you have to call to be able to submit.
So what does that mean?
Well, I mean, it's a lot of work for just putting in like one answer.
So who is going to participate? Like who is going to be in the survey?
People that self-select.
People that self-select, and that is called what?
Voluntary ballots, right?
And why is that an issue?
Because they have extreme opinions.
You usually get either only or at least mostly only people with strong opinions. If I didn't really care about the issue, why would I take the time to call in? If I did care, I would take the time to call in. And that might mean I'm really, really for or I'm really, really against. But that big group in the middle that doesn't care that much really wouldn't be represented. Now, side note, because this is something that happens a lot. They call your phone number and you don't answer. Is that undercoverage, voluntary response, or something else? What is it?
Undercoverage. I know it is, but
Non-response. What is it if they call my phone, they ask me to participate in the survey, and I hang up on them? That is also non-response. And I'm bringing this up with those two on purpose because this gets overlapped a lot as far as confusion. So the way I think about it is if I am doing a survey and I am keeping record of all my data, if I could write your name down that you are in my survey, then it is not voluntary response if you don't participate. So like, if I called your phone and you didn't answer, I could still write your name down. But if you saw something online where you could have chosen to participate and you didn't, I wouldn't know that, so I couldn't write your name down. Does that kind of make sense? And that's not like the textbook definition of how you should differentiate, but it's kind of a different perspective to think about it, to remember the difference between.
This might be a weird question, but what if you called in and then didn't respond?
It just wouldn't count.
Okay.
I mean, it would basically just be that you didn't call in.
Okay.
Okay, so now the actual question itself, it uses a stratified sample rather than a simple random sample. Does it use either one of those? No. People who feel strongly about the issue are more likely to respond. True or false? True. Viewers should be told about the issue before the survey is conducted. True or false?
No.
That one's kind of a weird one. Like, it's not bad because I didn't tell you, because if you're calling in, you probably knew about it, but it's also on the news, so we probably already talked about it. So not a terrible answer, but not a great answer. Some registered voters who might call might not vote in the election. Is it possible that that could happen?
Yes.
Is that our biggest issue there?
No.
No. The wording of the question is biased. We already talked about that and decided that it was not. B is your best answer there. Number 17. Statistics below provide a summary of distribution of heights for a simple random sample of 200 young children. And it's asking us about 100, so we're dealing with what? About 100 have this, so we're looking for, what is this? This of this. Half. So we're looking which one would be 50%. So 43 is the, like I'm looking at my answer choices down here. 43 is my what? 48 is, and then I'm using it again. So these first three answers deal with quartiles. E is my what? 46 is my what?
Outlier?
I mean,
Sorry.
how do you think that they came up with the numbers 40 and 52? Standard deviation from the mean. So like I think about it as like these two deal with mean and these three deal with quartile stuff. So I'm kind of gonna look at it separate. So quartiles, it's not gonna be spaced like this, but 25% in each chunk. Here's my first quartile, which is 43. My median, which is 45. My third quartile, which is 48. Less than 43 would be what percent? About what percent? Less than 48 would be between 43 and 48. But I'm going to keep going. What do you think I should, so like here, this is my terrible drawing of basically like a box plot. Here, I'm dealing with mean, so what do you think that should look like? Which one? So something like this, to where here is 46. What number is this going to be?
49.
Because 1 and then 52. And then here, this would be 43 and 40. So answer choice D says between 40 and 52. About what percent would that be?
95.
Because that's empirical rule, that's 2 standard deviations in either direction. 46, more than 46, would be about what?
50.
So right now it looks like we have 2 possible answer choices. But I made a huge mistake with what I just did. What mistake did I make?
Mean does not mean 50% above and below.
You assumed it was normal.
I assumed it was normal, and the problem never, ever told me that. So I actually can't use anything I did in D and E. So I don't actually know those percents at all. So a lot of times we take it for granted that it says normal in the problem, and you kind of forget that it says normal, and you just go ahead and do it the correct way. But if it doesn't say normal, you can't use anything with the empirical or yellow sheet or any of that stuff. So my answer ends up being C. And I think if those answer choices were switched, if D and E were A and B, I think more people would have missed this because I think they got to C and thought it was right and didn't keep going. Number 9. This problem is kind of a lot of work, but I want to talk through most of it just because this is a good problem to practice on. The stem plot below shows the yearly earnings per share of stock for 2 different companies over a 16-year period. What is that telling me? That's what my N is for each one of them. So looking at my words down here, I've got median, I've got range, I've got quartile, I've got mean, I've got interquartile. So I'm going to start with finding my 3 different quartiles for each one of them. More out of practice than anything. So how do I figure out where the median is going to be?
Count 8, or like count 8 and then take the mean of those 2 numbers.
So if I were doing it like a big bunch of numbers, I would take n plus 1 divided by 2, and that's where it would be. Because of this, it's pretty easy, so we know there's going to be 8 before and 8 above. So where do I start counting? Well, I'm just going to start. For company B, I would say 1, 2, 3, 4, 5, 6, 7, 8. This is between my 8th and 9th. Where would I start for company A? So this is my smallest number, so I'm actually technically starting here, going 1, 2, 3, 4, 5, 6, 7, 8. So which means median is between these 2 numbers. I have seen it on the AP exam, 26 being here and 26 being here. So just make sure that you're paying attention to stuff like that, because sometimes they've done it both ways. So now, what do I do with these to actually find this median?
Add them up, divide by 2.
Add them up, divide by 2. So it's, what does this number actually represent?
$1.21.
So it's got my key down here. So it's $1.21 and $1.43. So it's the middle of those 2.
$1.30.
And then here I'm between $1.92 and $2. And what is that one?
$1.96.
Median of company A is less than the median of company B. Is that true or false? That's false. Company A was more. Again, more out of practice than anything else. So I've split it in half. So now I'm doing it again. So there's 1, 2, 3, 4. Between these 2 is going to be my Q1. So that ends up being 1.9. No, wait. Not 1. What's it? 98, 3, 0.995. And then here, I would go 1, 2, 3, 4, and it's between here and here. And that one's a lot easier. What's that middle? 180. And then when I'm going to Q3, one, two, three, 4, so it's between here and here. That ends up giving me 8, 4, 6, 9. And then this one's between here and here. 7, 5, 5. Is that right? 2.755. I think that's right. Third quartile of A is smaller than third quartile of B. We can tell that's not right. Now I can go through this and find interquartile range. How do I find interquartile range? So I'm subtracting. So this one minus this one leaves me with 0.695. This one minus this one leaves me with 0.9. I don't know what it is.
0.695.
No, this
Okay.
one. 0.945? I think it's close. That may not be right. That's close. The only thing it says about interquartile range is this one is about twice this one. Is that true or false? Alright, so we're left with the range and the mean are things that we have to deal with. Which one of those is a whole lot easier to find? The range. Because if I had to find the mean, how would I have to find it? Add them all up, divide by how many there are. So range here, let's deal with, I'm getting in my words. The range for A, I would be subtracting what numbers?
The minimum maximum.
So 3.73 minus, and that leaves me with 253. What would I be subtracting for the range for B? So it gets funny with a back-to-back stem plot because you take it from different sides like that. So just make sure that you're paying attention. This one ends up being, I don't remember what that is, 171. So the range of company A is less than the range of company B. Is that true or false? So right now the only thing I have left is D. I can sit there and add up all these numbers, but does it look like the mean of this group or this group is going to be higher? The mean of A or the mean of B is going to be higher? You can pretty much look at that and tell that. And if I've already done all the work to eliminate all the rest of them, I'm probably going to feel pretty good about that one without actually going in and spending 2 minutes to type in all the numbers. Uh, 35. I am not reading the question at all yet, just looking at the picture. What? What is it definitely? What?
Influential giant.
So that's just kind of covering that again. Now, is it going to change things a little bit because it's not straight on the line? Yes. But there are points up here who are going to influence it even more than that. So even though that's not what the question asked, just kind of covering those two topics. The question says, what is the largest residual? And most of you are going to look at this question and really quickly go to the answer. That's fine. What is residual?
Observed minus predicted.
What on the graph represents observed?
The line. Or I guess
The dots are your observed. What is your predicted?
the line.
So how would I draw a residual for point A?
A line going straight down.
So I could do that for each one of them. Which one of those is the biggest?
A.
Like I said, the answer itself, I imagine, didn't take you but about 10 seconds to look at that problem, but I'm going to talk about other things. Number 3. A safety group claims that the mean speed of drivers on a highway exceeds the posted speed limit of 65 miles per hour. Just in that one sentence, what are important words? Exceeds, what else?
Mean.
And kind of this. What should you be thinking about when it says claims?
Test.
Null hypothesis. So just from that one sentence, what would I write as my null hypothesis?
Mu equals 65. And then alternative would be mu greater than 65.
So these two say null hypothesis. Well, I know that what has to always be in my null hypothesis. And those are not saying equals. So then my options with alternative, I have greater than, less than, greater than or equal to, and which one of those is correct?
Greater.
That one's a pretty straightforward question. All right, number 2. I'm going to talk about more than just this problem here. A researcher wishes to test a new drug developed to treat hypertension. A group of 40 hypertensive men and 60 hypertensive women is to be used. The experimenter randomly assigns 20 of the men and 30 of the women to the placebo and assigns the rest to the treatment. The major reason for separate assignment for men and for women is, so here I am designing an experiment. What do I always start with right here before I start doing my branches?
Like n equals 2.
And in general, these are all of my,
Patients.
whatever my individuals are. So here, what would I write if I were writing this one out? All of what applies to all of these people.
Hypertension. And then n equals 100.
So from here, what did they do? They branched out to how many?
To 2.
And what were they?
Men, women, and then 40, 60.
So I took my group and I split them, but I have not yet done any of what? And-
Assignments.
and assignment to get to those treatments. Now that I have men, what do I do with those?
Then assignment.
And then now how many would I split this one into?
2.
And one of them would be,
Placebo. The other treatment.
and then so this will be in something is 20, in something 20, 30, and 30. And then I would bring these back together to compare. I'll bring these back together to compare. What would I be comparing here?
Effectiveness.
And I can't remember what it doesn't give you much, right? We'll say effective. I like that. So the fact that we did this is called what?
Block.
Blocking. And we talked about this yesterday. Why do we block?
Because of the variable.
And that's in itself is correct, but to continue the wording for like helping us later
Cause the confounding variable.
may impact the response variable. So what did we block on?
Gender.
Gender. Why?
Because they might be affected differently.
Because it might impact our treatment differently. So what is the correct answer here? Wait, so is it too large to use 100?
No.
Might the new drug affect men and women differently?
Yes.
Would that be a reason to block?
Yes.
The new drug may affect hypertensive and non-hypertensive people differently. Is that true?
Yes.
Is that why we blocked?
No.
No, that's the whole point of our test, or the whole point of our experiment, but that's not why we blocked. Uses matched pairs, didn't even use matched pairs. Must there be an equal number in each of the groups?
Yes.
I mean, no.
Is that a requirement? No. Is it probably good to?
Yeah.
Yes, and we also did in this one anyway. D is your answer. And the last one, number 8. A high school physics teacher was conducting an experiment with his class on the length of time it will take a marble to roll down the slope chute. The class ran repeated trials in order to determine the relationship between the length in centimeters of the slope chute and the time in seconds it took the marble to roll down the chute. A linear relationship was observed and the correlation coefficient. This is what, if I were reading through this, what would I associate with that right there? This directly means R. And so I would associate this with linear relationship, yes. After discussing their results, the teacher instructed the students to convert all length measurements to meters. What does that do to correlation?
Nothing.
Absolutely nothing. So, correlation will decrease, correlation will decrease, correlation will decrease, correlation will increase, correlation will not change. Correlation is not impacted by changing units. Correlation also does not care which one is X and which one is Y.